Today, we're going to walk through the basics of a Garmin Marine Radar. Let's start with how radar operates. Radar is very similar to sonar, where sonar is under the water and radar is above. Both operate with a transmitter sending out a burst of energy. The energy bounces off the targets and reflects back towards the source, where a receiver picks up that return and translates the time it took to receive the reflection into distance. The reflections are then drawn on screen to show your position and the relative position of the targets. In addition, because the radar is rotating, we can determine not just the distance to the target, but also its bearing. A larger target will typically reflect more radar energy back to the receiver, which translates into a larger image on the display. One of radar's key features is that it can see even when you can't. A dark night, fog, or rain can all severely limit your visibility, while the radar can burn through those conditions and see another boat coming at you in the fog or make out that approaching shoreline. So what makes one radar different from the next one? Power output is one way. Garmin makes radars that output a wide range of power, from 40 watts all the way up to 25,000 watts or 25 kilowatts. The greater the power, the more energy that it can send downstream, and the greater possibility of that energy reflecting off of a target and returning to the radar. A more powerful radar will have a better chance of picking out a marginal target than a less powerful radar. It will also provide more range than a lower power radar. Another important factor is the size of the antenna. The bigger the antenna size, the better resolution of the image. To understand this better, we need to look at something called horizontal beam. Horizontal beam is a measure of how broadly or narrowly we can focus the radar beam. When energy is output from the antenna, the wider the antenna, the more we can focus that radar beam. For example, our 6-foot open array allows us to focus that radar beam down to just over 1 degree. On the flip side, the 18-inch domed radar only allows us to focus that beam down to 5 degrees. Let's look at an example. Let's say you're offshore and you're approaching an unfamiliar inlet late at night. This inlet has a navigational aid on both the north and south side, separated by a few hundred yards. You're approaching the inlet in the dark, trying to figure out where to go. The smaller dome radars will rotate around and see the buoys, but because of the wide beam, the two buoys are seen on the same radar pulse and appear as one target. Whereas with the open array, the narrow beam allows us to see the first buoy, rotates a little bit, and sees the second buoy as a separate and distinct target. The same thing would happen if you have two boats coming at you in close proximity. The open array will be able to separate those two radar targets better and more accurately and give you a better radar picture due to the narrow beam width. It is like comparing a spotlight to a floodlight. A spotlight can reach out and touch something far away thanks to its focused beam, while a floodlight scatters light all over the place and doesn't reach very far. That brings us to the range of a radar. While a radar with more power and a narrower beam will see farther more clearly, there is still a horizon, just like your eyes. This horizon can be calculated by measuring the height of your radar from the waterline. Then, take the square root of that number and multiply it by 1.22. As an example, let's take a center console boat with a T-top, and let's say the radar is 9 feet off of the water. The square root of 9 is 3, and 3 times 1.22 is 3.66. This means that the limit of the radar sight is 3.6 miles away. However, we have to take into consideration the height of the target. So in theory, if your radar was looking at another center console with an overall height of 9 feet, you could add another 3.6 miles to our distance for a total of just over 7 miles. The range of the radar, with a potential maximum radar range of up to 96 nautical miles, depending on the radar. To recap, the more power a radar has, the better the image can be and the farther it can travel. In addition, the bigger the antenna, the better returns and clearer target separation it can have. That covers the basics of how marine radar systems work and what things to keep in mind when looking for a radar system. For more help, visit marinesupport.garmin.com. Thanks for watching.